Give me a minute or two to get my computer loading up. While you're waiting, though, just work on any of the challenge ones that you haven't finished. The handout that hopefully you picked it up when you signed in, we'll start work. We're going to finish that handout after we finish the challenge problems. Alright. And we're gonna the challenge problems. These are the ones I have to make sure we finish. Did I should have gotten to number 8, didn't I? Yeah. Did I finish it or did I finish?
Yeah.
How far did I get?
Oh, I think we got this. I think we're on 9.
We're on 9? Okay. Alright, so let's go to 9. Do me a favor, go ahead and go through it real quick and then see if you can finish it if you haven't finished it. Okay? I'll give you a minute or two. Let's take a look at number 9. You guys realize on number 9 you had to check and see whose work is right, whose work is wrong. What do you guys think? Stephanie's right or Adam's right? You think Stephanie's right? You think Stephanie's right? Let's check. We're not sure yet, right?
Wait, no,
You think Adam? Now, when you read the problem, you guys agree both of them did the drawing correctly of the cat? They're both in the wrong spot. What's the only thing that's different?
where the degrees is.
Where the degrees is. So in the statement, you guys see that this is the key right here to figure out where if the angle is in the right spot. Now the cat, if the cat's looking straight, its angle of depression would be like this. Yep. Now, one thing that you got to notice is if the angle of depression should be the same on both one, right? But you notice that this angle here and this angle here are the same. This line is a parallel line to the horizon. Alternating tear angles are always equal, so the person that's correct is Adam. He put degrees in the right spot. If you use this one to solve it, your answer's wrong. Okay?
If they're equal, what makes Stephanie wrong?
Because that's the opposite. This is the adjacent, and that's a very good question you asked. Look at Adam. Opposite is the height of the tree. adjacent, you see they're switched around? You switch that around on the calculator and you're going to get two different answers. Yeah. So, did you guys see how to solve for the correct work? Not Stephanie's. Her drawing is almost correct. It's just off. Okay. She put the angle, should have been 28 degrees. Now, yes, the angle of elevation is from the top going down, but this angle right here is an alternate interior to this angle right here. Okay? Where do you guys get on that answer? You guys get that number? Yeah. And that number is in meters. Any questions with that one right there? Now, do you guys see that answer, question number 10? Yeah. Okay. All right. Now, go ahead where you're at. Pause for a minute so we can see how your drawing is compared to mine. Okay. Now the mountain can be drawn several different ways. You can draw the mountain like that, if you wanted to. Now, what it's really trying to get you to visualize, though, is that you are "17 miles from the base of a tall mountain." The mountain could have been drawn like this. In black. Okay. Now we want to get a couple of things labeled here. You stare at it at an angle of elevation of 4 degrees. When they move 12 miles closer to the base of the mountain, what will be their angle of elevation when they look to the top? So, one of the things that you have to keep in mind is that you don't know the height of the mountain. In order for you to get the height of the mountain, which one of the three do you guys think we should use? Which one do you think we should use? Sine, cosine, or tangent?
Cosine.
Cosine? Jonathan, which one do you think we should use? Cosine? And tangent? Everybody agree this is the angle that we know? This side should be labeled which one of the three?
Opposite.
That's the opposite. This one should be labeled adjacent. And the 90-degree angle is from the height perpendicular to the base. Over here, this is your hypotenuse, yes? Which one has opposite and adjacent in it? Tangent. So we're going to do tangent of 4 is equal to x over 17. And you guys notice that the units are in miles? Just keep that in mind, okay? We're talking about miles right now. How would I solve that for x? Go ahead and multiply by 17 to both sides. So 17 times tangent of 4 And all three of you guys should get the same number unless your calculator's in the wrong mode. Cole, what do you get on that one?
1.18.
1.18?
Yeah.
Any number after the 8?
8.
Another 8? Okay. Are you guys getting the same number?
Yeah.
Make sure you're getting the same number. If you're not, you need to check the mode that you're in, okay? All right. Now, take a look at the problem. Did we finish it? Cole, you think we finished the problem? Dominic, you don't think so? What else are we missing?
The angle that he's looking at.
Okay. There's another angle that they're asking for, yes? In the problem?
When they move 12 miles closer.
Ah, when they move 12 miles closer to the base of the mountain, what is the angle of elevation? So you got to keep in mind something here. They're moving 12 miles closer, so now you got to keep in mind, from here, go 12 miles closer. What's this distance then? 5. That's 5. And you guys understand? All you got to do is 17 minus the 12 that you're moving gives you the 5 miles. That's how far you're to the base of the mountain.
Wasn't that like some other problems?
Uh-huh. Now, it's going to get a little messy here, so let me kind of clean it up. Do you see this triangle right here? 5 theta is the angle that they're asking you for. Did the mountain change height at all? It's still 1.88. Yep. All right, so what will help us figure out the angle measurement then? Which one of the three? Sine, cosine, or tangent? Which one do you think, Jonathan, will help us? Sine, cosine, or tangent? Tangent. Tangent has opposite and adjacent in it. Do we have those two sides? This is the opposite, and this is the adjacent. So do you understand why Jonathan is correct? It's tangent that you want to use, yeah? So all you got to do is tangent of the angle. Now remember, we don't know the angle, right? Is equal to 1.188 divided by 5. Do you guys know where the 5 came from? How many you know how the 5? How come I'm using 5?
Because
They moved 12 miles closer. What do you think is going to happen to the angle? Should the angle be bigger than 4 degrees or smaller than 4 degrees? You guys agree? The closer you're getting to something, and the height stays the same, now you got to look up higher. Yeah? So common sense, you guys realize when you get your answer, it's got to be bigger than 4. If it's less than 4, something's wrong. Okay? All right, so tangent of theta is equal to 1.188 over 5. Do you remember how to get the angle from there?
the inverse?
Yes, inverse. So go ahead and do tangent inverse of 1.188 divided by 5 on your calculator. Tell me what you guys get. Anyone, whoever gets it first.
I got 13.6.
All right. Anybody else get the same number? Yes? Jonathan, you getting that number? Yeah? Okay. Now that number represents angle measurement, okay? So that's 13.36 degrees. Does that sound pretty like a good number? Yeah. It went from 4 degrees, but they were 17 miles away, right? They moved up, and now they're only 5 miles away. Does it make sense? 13 degrees probably is a pretty good it's bigger than 4, isn't it? Yeah. And they moved up more than half the distance, so that means the number should be more than twice 4. So bigger than twice 4 is 8. And this number is more than twice that. Yeah. Now, does this make sense? If they would have went half the distance, that angle should increase by 2. Because you're getting closer to it, so whatever is being changed, there should be a change in elevation. Alright, so kind of use common sense when you guys are doing these problems. Think about it, alright, does that even make sense or not? If I would have got a negative number, do you guys see that something's wrong with that? You can't, you should be getting negative numbers in angle measurements, yeah? Okay. Does that one sound okay to everybody? Yeah? Alright, can you guys try to set up number 12 if you haven't done it so already? Give you an extra minute if you need to, and then I'll maintaining. When it says maintains 25,000 feet, it doesn't matter if you're looking at the plane when it's right there in the sky or over here in the sky. It's 25,000 feet. And you guys realize we base everything off of the sea level? Yep. You guys know how high we are over here in the high desert when you get to the Cajon Pass? You know that?
7 or 12?
12 what? 12,000 is a lot.
4? Is it a 4?
4,000. Next time you guys come up to Cajon Pass and you can see the daylight and you can see the sign that says elevation when you make it to the rim. When you get to the rim of the Cajon Pass, it'll say elevation 4,272 feet. That's at the Cajon summit, the very tip of the Cajon. But you guys realize after that it's you drop. Yeah. We're not at 4,200. We're just maybe 3,600 or something. But you'll typically realize we're roughly the 4,000 feet area. Big Bear is higher than us. Have you guys been to Big Bear? Big Bear is roughly about 6,000 feet and up. And I mean the city. The city. When you go, you guys been to the city of Big Bear? And you guys notice when you get to the city of Big Bear, when you first get there, it's hard to breathe a little bit. You feel tired because the air is thinner as you go up. Okay. All right. Now, so the plane is traveling and it maintains that altitude. So do you understand it's always staying that high? Okay.
So that means it's going to be a straight line.
It's a straight line up, and then it's a straight line here. So you guys understand these lines are parallel to each other, the ground and the flight pattern that the plane is taking. Then it says the pilot observed the crater on the ground of an angle of depression. So it observed the crater. Interesting, they say here. At an angle of elevation or of an angle of depression. What did it say? Elevation or depression?
Depression.
Does this make sense that the pilot is looking down? Yeah? So the pilot looks down at an angle of depression. So do you understand? You gotta imagine that straight line going forward and the line goes down like that. That angle of depression is 5 degrees. Do you guys understand? That angle and this angle here are alternate interior angles if lines are parallel. So that means this is the side that you would label what?
Opposite.
Opposite. Over here would be your adjacent, and then the hypotenuse, do you guys agree it's the perpendicular line? It's opposite the 90-degree angle. Always hypotenuse opposite the 90, okay? Alright, so I took up a lot of space to draw this, okay? You didn't have to take up that much space, okay? You could have easily just angle of depression was 5 degrees, so this angle here is 5 degrees because the plane is flying always at 25 If I write 25K, you guys understand I mean 25,000. Yeah, okay. And plane's over here. Alright. If the plane continues for 16 miles more, what will be the angle of depression? So you got to keep this in mind. If the plane goes for 16 more miles, when it sees the crater, do you guys agree that the angle of depression is going to get bigger? Because now they're closer, so they got to lift down more. What is that angle of depression when they get, how many miles? 16 miles closer. So first thing that you got to do is, first you got to figure out this distance, the side that's adjacent. What do you think that side that is adjacent, what does that side represent in the problem? The ground.
Distance of like where it was to where it will be.
There you go. It's the ground, and it's the distance from the plane to the ground, how far it is to the crater, yeah? So you need to find out that distance, because then you have to do what happens when you go 16 miles more, yeah? Now there's another problem that we're going to have to face, and I won't say anything about that problem yet. Can I find how far is the plane from ground-wise to the crater? How can I figure it out? Sine, cosine, or tangent? Which one of the three do you think would work? Tell me which one do you think would work? So my suggestion always is write it out. Look at what information you have, okay?
Need to find the what?
So we need to find this distance, that's adjacent side.
Sine.
Alright, sine is opposite over hypotenuse. And you see opposite, the hypotenuse is right here. Do I need the hypotenuse?
Oh.
Because that's what I would end up solving for, is the hypotenuse. Do I need it?
Yeah.
No. Notice the hypotenuse is the height, is the direct line from the plane to the crater. We want the distance vertically from the plane on the ground to the crater. So it's tangent. So tangent of 5 is equal to 25K over X. Solve that for X. You guys remember what to do right there? Tell me, what do you think, Colin?
Times it by X.
Mhm. First thing is you gotta times it by X. You can't leave that X on the bottom, okay? All right, Cole, what do you think we can do next? Because now we don't have X on the denominator. What should we do next, guys?
Divide by tangent both sides.
Divide by tangent of 5. Make sure you write that step out. Tangent of 5 divided by tangent of 5. Same thing divided by same thing always equals 1. Okay? The only one it doesn't work for is if you had 0 divided by 0, that doesn't give you 1. 0 divided by 0 is 0. Okay? Now go ahead and type in 25,000 divided by tangent of 5. Did you get done with it?
So 200. 28575.3076.
Alright, so we'll just say 0.3. Yeah? Are you guys getting the same number? No, Jonathan? Okay. Make sure, Jonathan, make sure you type in 2,500. Jonathan? And then when you hit division, tangent of 5, you can close that parentheses and hit enter. You get that number now?
Yeah.
Okay.
The only thing that's different on mine
Uh-huh.
is that they're right after the 5 in order, but then it's 0.13.
Really?
Mm-hmm.
You don't get the 0.3076?
Yeah, but it's just the decimals in a different spot.
Oh, did you write 2.5 with only 2 zeros?
Probably. I'll check. Mm-hmm.
Okay. That's why, because you're off 1 digit. That's why. Notice your decimal's off only in one place. Okay, so you see how to fix that, right?
Mm-hmm.
Now, this number, does it represent what type of units?
Miles.
Are you sure? Because isn't the 25,000 in feet? So that means this is in feet. We haven't used miles yet, but do you guys realize, here's that next problem. They're asking, what's the, we haven't answered the question, you guys realize that? Do you know where you're supposed to answer now?
How many feet are in miles?
Nearest.
We need to have to find out how many feet are in a mile, and what do you think, Dominic?
The nearest degree.
Not the degree, okay, yeah, we are gonna find the answer to the nearest degree is what we need to get. But now remember, they say that the plane went on and it went for 16 more miles. You realize that right now, the plane is 285,751 feet away. If you were to subtract 16 from that, your units are not the same, and your numbers are already wrong. Can we convert the feet to miles? Do you remember the number, how many feet are in a mile?
Something.
5,000.
On the 5,000.
5280. 5,280 feet equals 1 mile. Yes? So what are you going to do with this big number that we just got?
Can you divide the x by 500?
You're going to divide this answer x by 5,280, and that'll tell you how many miles those feet equal. When you get that, can you give me an approximate to the nearest tenth?
I got 54. 11.
Got 11. Okay. Jonathan, same. Dominic? Yep, okay. All right, so when you did 285,751.3 and you divided that number by 5280, you got this number, right? All right, that means, pay close attention, the plane right now is then 54 miles away from the crater when it first looked down, right? And the angle of depression was 5 degrees. How far is the plane when it goes 16 more miles then? What are you going to do with that 16?
Add it or
Think about this. You're 54 miles away to the crater. If you travel 16 miles closer, should your distance get further away, or should you?
the closer, so you subtract it.
Yes, you subtract that number.
From the 54.
Yes, and remember you have to take away the 16 from the 54. If you were to take the 16 away from the 285, remember that those are not the same types of units. So take away the 16 from the 54.
38.11.
All right, 38.11, everybody agree? All right, so this is, I'm gonna draw another little triangle, so just everybody watch. 38.11 is the new distance from where the plane is on from the ground vertically up to the plane to the crater. Did the height of the plane change?
No.
You're gonna find out theta, that's the angle of depression right there. Do you think that the angle is going to get bigger or smaller since the plane got closer? It's going to get bigger because they got to look down more. Does that make sense? Yeah. All right, and do you guys realize I'm going to use tangent is opposite over adjacent? What does the opposite side measure? 25K, but that's in feet, isn't it? Should I leave it in feet?
And then convert it to miles.
You gotta convert it to miles because this is in miles, okay? So you gotta convert the 25,000 feet into miles. So 25,000 feet is the same as how many miles?
4.73.
4.73, okay, so everybody check.
Yeah.
And what you should have done was 25,000 divided by 5280. Getting that, Dominic? So that's 4.73 miles. Okay? Is that right? All right, so 4.73 miles. All right. I'm going to have to get into the space down here from the other problem to finish my answer, okay? So I'm going to do tangent of theta is equal to opposite, which is 4.73, divided by 38.11. And you guys remember what to do right there? Tell me what to do. Inverse of tangent. Tangent inverse of 4.733, or 4.73, sorry, divided by 38.11. Somebody give me a number.
7.07.
7.07? Everybody, are you guys getting the same number? Yeah? Is that measurement, what kind of units is it? Theta always is
Degrees.
degrees. So do you guys agree that the angle that they're looking down is bigger than 5 degrees now because they got closer? Yeah. So the answer is in degrees. Remember, whenever you're solving for the theta, the angle, that's always in degrees, okay? All right. Now the next problem is going to be pretty challenging, okay? See if you can set it up. I'll give you a minute or two to see if you can finish setting up that last problem, yeah? Try to really think and really try to see how much you do the way I'm going to set it up. Make sure, just watch. I'll give you some time to write stuff down, okay? Just mainly watch, okay? My calculator. All right. Okay, so first it says an observer on the ground looks up to the top of a building at an angle of elevation of 30 degrees. Everybody see where the 30 degrees is? I'm going to draw a dot here, and I'm just going to say that's one of the persons is A. Okay? All right, does that line make sense why I would draw that line? Okay. And just remember the clinometer when you guys were checking the height of the tree? Okay. And then it says, after moving 50 feet closer, So do you guys agree that from A to B is a difference of 50 feet now? Now 50 feet closer to the building. Do you realize you don't know how far you are away from the building? That's the X value. All right. And then B, you see that the person got closer. Does it make sense their angle of elevation should be bigger? Did the building get taller? You just got closer. So you got to look up higher, don't you? Okay. So, first thing we got to do is set up an equation that represents the situation from the first vantage point. The first vantage point was which one? A or B? A. I have the angle. Do you guys see that this is the opposite side of that angle? And then all of this represents the adjacent side. Yeah? Out of the three, so ka, toa, you guys realize which one we're going to use. Jonathan, which one do you think we should?
Choose tangent.
Tangent? Very good. Everybody agree tangent is going to be the opposite and the adjacent? Now, we're going to write an equation though for the first vantage point. So do you guys realize we're using the 30-degree angle, right? So you have to set up tangent of 30 is equal to the opposite represents what? No, not X.
So over adjacent.
Yeah, opposite is the Y. And the adjacent is the not just X. 50
X.
and the X. How would you say that? Imagine I cut a piece. This piece measures 50, this piece measures X. How would you say that the total was? Mathematically.
50 minus X.
So if you were here and you got 50 feet closer, the total distance should be 50 minus X. Now remember, X represents from the second vantage point.
X plus 50.
It should be X plus 50. The total distance to the first vantage point. So do you understand why that side is considered X plus 50? Yep. All right, so that answers this question right here, okay? Everybody okay right there? Now, I am going to do something with that problem, but I'll wait until we do the second one. Okay? Can you guys try to set up something for B using the second vantage point? On the second vantage point, which is the angle we're going to use? The 40, okay? So set up tangent of 40 equal to what?
Y over X plus 50.
Now, do you realize the second vantage point, the distance to the building is just X? Not X plus 50? Remember the x plus 50 is just for the first vantage point. Does that make sense? So you're just going to write tangent of 40 is equal to y over x, okay? Now right there, you've answered question A and you've answered question B. Now I want you to look at something. Is the height of the building, is it going to change anytime soon? Do you see that they're both missing the height of the building? Okay. The other thing is, do you notice that the 50 feet is a measurement that we have, but it doesn't help us that much? Because we don't know how far it is for x. If we knew what x was, we would just add 50 to that, and then we would know the adjacent side to use the 30-degree angle. I don't know that. I don't know what that distance is of x, and that limits my distance of x plus 50. Everything is revolving on how far is this 40-degree angle away from the building, right? But do you realize that they're both of those equations have the building in common? So that's going to tell me then multiply by x plus 50 to both sides. And when I do that, I get x plus 50 times tangent of 30 is equal to y. Now there's a reason why I want you guys to know what I just did. I just set up this equation equal to the height of the building, okay? Can I rewrite the second equation so that it's equal to the height of the building? And if I can, what should I do to rewrite it on the second equation? Go ahead and do that. Show that on your work, times it by x, and that'll give you x tangent of 40 is equal to y. And now you guys see that both of them have the equation set up so that they're equal to the height of the building, which is the letter y. Now before I do this next step, I want you guys to take a look at something. This tangent of 30 is going to be distributed into the x plus 50, so I'm going to rewrite it. So just look, just pay attention, okay? X times tangent of 30, do you guys agree, is x tangent of 30? Plus 50 times tangent of 30 is equal to y. Does everybody see how I wrote that right there? Okay. All right, so do you guys agree that they're both equal to y? All right, so now we're going to set up both of the equations equal to themselves. Since they both equal, do you guys agree y is equal to y? Are you equal to yourself? You're equal to yourself? So do you guys agree? If this is y, it should be equal to that y. Isn't that the height of the building? It should equal itself, shouldn't it? Building is not getting bigger or smaller, right? So that leaves me, I can do this then. X tangent of 40 is equal to x tangent of 30 plus 50 tangent of 30. Now just breathe, soak it in, look at my new equation. You notice the only variable in the problem is the letter x now? So that means there's no y's in there, right? I can solve this equation for x, meaning I can figure out how far is the 40-degree angle away from the building. Yeah? You have to be able to move the equation around. This is a term multiplied by x, yeah? You guys see that this is a whole term added to another term? It's like saying 3x plus 4. Yeah? So if I had, and this is like, this is saying like this is an x times 2 or a 2x. So this is, let's say, just to kind of put that as 2x equals 3x plus 4. How would you solve this equation for x? 2x equals 3x plus 4. How would you solve it?
Transfer it.
Okay. Does my work make sense? And I just randomly threw up an equation, okay? Does this make sense then? Those disappear from the same way I moved to the, you told me to move the 3x minus the 3x, yeah? That leaves me with x tangent of 40 minus x tangent of 30 equal to 50 tangent of 30. Okay, before I do anything, what you're doing is you're manipulating the equation to get what you want. And what we want right now is we want to figure out how far is the 40-degree angle position to the building. Because the minute you know that information, you'll figure out the height of the building. You guys notice that this says x times tangent of 40? And this says x times tangent of 30? If I factor out that x, it leaves me with tangent of 40 minus tangent of 30 equal to 50 tangent of 30. Now, watch closely. If I were to distribute it back in, x times tangent of 40, does it give you x tangent 40? Yeah, I just don't know what x is, right? X times negative tangent of 30 is negative x tangent 30, right? So I can prove that I can go backwards if I need to. But I don't want to go backwards, okay? I only have one step left to go, and I can get the letter x alone. Pretend this says x times all of this is one number, right? Can you type in tangent of 40 minus tangent of 30 on your calculator? .822, so I'll type it on my screen. What is it, tangent of 40?
Yeah, minus
40, and be careful when you do tangent of 40 minus tangent of 30. Does everybody see on the screen you have to close the parentheses right there? Because if you put minus and you don't close the parentheses, it's going to do 40 minus tangent of 30 first, and then it'll take the tangent of that number. And I'll show you how somebody could easily mess this up, okay? That's the number decimal for tangent of 40 minus tangent of 30, but watch how you can mess it up easily, okay? Tangent of 40.
That's what I mean.
And here's what the calculator is thinking. You're telling the calculator, do 40 minus the tangent of 30 first. Whatever decimal you get from that, then get the tangent of that. And that's not what we're trying to do. You see that numbers are different? And that's because the calculator's only as good as you tell it what to do. Right there, by not putting in this parentheses here, if you don't put that parentheses there, that's going to cause a problem right there. And this answer right here, that one's wrong. Do you understand that part? Okay. So do you guys agree that tangent of 40 minus tangent of 30 is just a decimal 0.26? Okay. So if it was written like this then, 0.26x is equal to something, how would you solve for x right there? Divide. Just divide by whatever that is, right? So just divide by that to the whole problem. So go ahead and write tangent of 40 minus tangent of 30. Divide that by both sides. Now you already know what the decimal value is for that. You guys saw the number we got was 0.26. If you want to, you can type in 50 tangent of 30 divided by 0.26 approximately, wasn't it? 0.2617. I would say 0.262 would be a better number to estimate. So if you want, go ahead and type in 50 tangent of 30. And whatever you get from that, then hit divided by 0.262. What do you get? 10.00? Cool. Okay. Jonathan, 10.00, you getting that number? Yeah, actually, you got that? All right, let me show you something on the calculator, okay? I'm going to clear all that. This is what I'm going to type into the calculator. You guys see what I circled in blue? I'm going to type that into the calculator, but I got to be very careful. I got to make sure that the top is considered the numerator. So I have to use a parentheses at the beginning and a parentheses at the end that says this is the top. Okay? So I'm going to do something like this. You guys see those parentheses on the top over parentheses on the bottom? I just got to fill in what goes in those parentheses, right? So let me show you. The top says 50 tangent of 30. Now, I'm going to stop right there because I want you to notice something. You notice I started it with a parentheses, right? And I hit 50 tangent of 30. I have to close with two parentheses. One of them because of the 30, okay? But then I got to use one more, and that says all of that is the numerator. Then I can hit the division button, okay? Now I'm going to do the same thing on the bottom. I'm going to use a parentheses to start it, and then I got to keep track that all the parentheses that are going to pop up when I do tangents get closed, okay? So I'm going to hit starting one, and then I'm going to hit tangent of 40. And when I hit tangent of 40, do you guys realize I have to close that 40 right now? And then I'll hit minus tangent of 30. And I have to close the 30. And then I have to add one more parenthesis because I said I'm going to start with a parenthesis. Okay? And that is the most accurate decimal value you can have, is 110.28. Okay? Now, do you guys realize that that is just the distance from the 40-degree angle to the building? And we haven't figured out the height of the building yet? So our answer is 110 point, I'm going to say 110.3, okay? Yep. So the adjacent side, x is equal to 110.3, and this is feet. How do I find the height of the building? To get the height of the building, all you got to do is, and this example that I wrote right here was just to show you how we were going to move some stuff around. So the height of the building then is tangent of 40 degrees is equal to y over 110.3. Now let me throw something at you guys. What if I would have said tangent of 30 degrees? Yeah, you have to use the 110.3 plus the 50 on that bottom. If not, your answer would be wrong, okay? So go ahead and solve for y for me, everybody. Everybody agree, multiply by 110.3 to both sides? So what's 110.3 times tangent of 40? It's 110.3 times tangent of 40. What do you guys
Yeah,
get?
92.5.
92.5. Okay. Dominic, seeing the same thing? Yeah. Cole, you getting the same thing? 92.5? Yep. Check this out. What if I didn't do tangent of 40? And I did tangent of 30. I did tangent of 30. Do you guys realize the building height is still the opposite? But the adjacent is 110.3 plus the 50, so that's 160.3. So go ahead and multiply 160.3 to tangent of 30. What do you guys get?
92.54.
92.54? Is that pretty darn close to what the other problem had? Yeah. Now you guys got to realize, because we're using decimal estimates from all of this, that's where things start to go off by a little bit. Okay. Okay. Now that one is a challenging problem. I'm not going to give you one like that one. Okay, everybody okay so far? It was hard, yeah. Sometimes things in life are not easy. And we have to work our way around things and learn to stay focused when things get hard. You know, don't just give up, okay? Don't give up, all right? All right, now, wherever I'm at, I'm going to move on to the next part. So everybody have your handout. The one that you picked up when you signed in? Yeah. All right, now I'm gonna leave you guys to read through the rest of it. I need everybody to focus though on this theorem. Put a star there, it's very important. All right. From this theorem, we're gonna solve a bunch of problems. Sometimes you guys are not gonna be able to use sine, cosine, or tangent. And if you know that the triangle is a 45, 45, 90-degree triangle, then you can solve for any of the sides. Okay? Now, you are going to be able to use sine, cosine, and tangent if you have one of the angles and one of the sides only. If you have one angle and one side, you can use sine, cosine, and tangent. But if all you have is all the angle measurements, the only thing you can do is you can get an estimate of the sides as proportions, okay? All right, so what I want you to do, you guys see this space right here in your notes right now? Do me a favor, I want you to write 45.4590. All right, everybody wrote that down? All right, now watch this. Everybody see the 45-degree angles right here? Okay, look at this. Opposite the 45-degree angle is the side that's labeled S. It kind of looks like a 5. We're going to put an S, and an S square root of 2, like that underneath it, okay? Now the S might look confusing to you because it almost could look like the S looks like the number 5, doesn't it? So what you can do is you can do this then. The ratios are 1 to 1 to 1 square root of 2 if you want, so it doesn't confuse you on what is S, okay? S is really represents, if those sides all each measure 1 unit, the hypotenuse is 1 square root of 2, okay? Now, do you guys understand 90 degrees is opposite the hypotenuse? Yep. Okay. All right, so the next one, we're going to do this problem right here, number 1. The examples, I'm going to leave those for you guys to read and go back on your own, okay? So what I want you to do first is, it says, find the length of the hypotenuse of a 45, 45, 90-degree triangle with legs of length 5 square root of 3. So do me a favor. Draw a triangle that has 2 sides equal to each other. Somewhere in the space right here provided. Doesn't have to be perfect, mine's not. All right, in your picture, can you label which sides are equal? Remember, you don't know the side lengths, right? So do you know what to use?
No.
Little tick marks? Okay, your hand gesture was telling me that that's what you were going to say. The little tick marks. And then you also got to label the 90-degree angle in the picture. So everybody, did you guys draw this little square here on the corner right there? Yeah? Okay. In this picture right here, if that's all you're given, then you need to know if these 2 sides are equal, the angles opposite those sides are also equal. So let's pretend I don't know what those angles measure, but I know that they're variables, so, and you don't have to write this part down, okay?
You should do like the circle, half circle thing for the angles also.
Oh, okay. The angle arcs, yeah, those arcs are congruent. I don't know what those x's are, but I know if x plus 90 equals 180 degrees though, right? And you don't have to write this down, I'm just trying to prove a point that I know that that picture is a 45, 45, 90 degree triangle, okay? That's 2x plus 90 equals 180. Take away the 90 to both sides, and you're left with 2x equal to 90. Divide both sides by 2, and each angle has to measure. 90 divided by 2 is 45.
Quick question. If you can tell that a triangle has a 90-degree angle, does that mean that all the other sides are always going to be 45?
No. All it means is it's a right triangle, so either you can use Pythagorean theorem. If you know 2 out of the sides, you can find the third one. A squared plus b squared equals c squared. If you only know 1 of the sides and 1 of the angles, you can find any of the other sides using sine, cosine, or tangent. Now it all depends which angle do you have. That determines which one is the opposite side and which one is the adjacent, remember? Hypotenuse, though, is always on the other side of the 90-degree angle, okay? Right. Just whenever you see the 90-degree angle, draw a line from that to the side opposite, because that's the hypotenuse, yeah? Do you guys agree that in this picture, that's a 45, 45, 90 triangle, even though you don't know any information? The labeling says 2 sides are equal? Okay. So in this picture, it says, where are the legs? So the legs are these right here. And you guys agree this is the hypotenuse? All right, so the ratios for a 45, 45, 90, the ratios were S to S to S square root of 2, yes? So here's what you got to do. It says find the length of the hypotenuse, so they're asking you for this length. It says the triangle, it's a 45, 45, 90, and the legs have a length of 5 square root of 3. So that means if this one is 5 square root of 3, the other one is also 5 square root of 3. Okay? So here's where it gets interesting, okay? You guys see this part right here that I set up? Right there I'm going to set 5 square root of 3, 5 square root of 3, and x. Do you guys agree this opposite the 90-degree angle is the hypotenuse? I need to solve for x. X is equal to s times the square root of 2. Do you realize I have a variable equal to a variable times the square root of 2? I don't have any information in it. But watch this. Right there, it's telling you that s is equal to 5 square root of 3. That means s is equal to 5 square root of 3. Well, again, 5 square root of 3, 4s right there. And it'll look like this then. And now x is equal to 5 square root of 6. Now, you see how the 6 came up to be?
Because it's the answer of 5 squared. 5 square root of 3, then that answer is the square root of 2.
And because it's multiplication, only the things that are inside of a radical in multiplication, only those things can multiply together. Anything that's on the outside of a radical, it only multiplies with anything on the inside of the radical if you can after you convert it into a decimal, or if it's a perfect square, it'll come out to be a nice even whole number. But notice that the 3 and the 2 are both inside the radical. Those can multiply together. 3 times 2 is the 6. When you guys start doing problems in the rest of for this first semester, I need you guys to be able to put answers in simple radical form, which means don't give me the decimal value. So, but let's check. Let's take a look at what does the decimal look like for this. Yeah? So grab your calculators and type in 5, and you can clear everything else if you want. Type in 5 radical, and you guys know how to get the radical symbol on your calculator? Just hit the second button and find the x squared button. And then go ahead and put the 6 in there. And you guys see the number I'm getting? Yeah. Watch this. Remember it was 5 square root of 3 times square root of 2? Watch. 5 square root of 3, get out of the square root symbol, times square root of 2. Everybody agree that says 5 square root of 3 times square root of 2? See, I got the exact same decimal. Okay. I need you guys to get in the habit of being able to write them in simple radical form. Okay? All right, do me a favor, go to the next page where the 30, 60, 90 degree triangle is. And can you go ahead and write these ratios right there for me? Just keep in mind, opposite the 30 degree angle is the S. Opposite the 60 degree angle is S square root of 3. Opposite the 90 degree angle is 2S. Now if the S's look confusing to you and they look like 5s, just think of them like this. The ratios are 1 to 1 square root of 3 to 2. Okay. Yeah? Because 2 times 1 is 2. Alright. Alright, so let's practice a couple of these. Alright, everybody go to number 1. And the first thing I want you to do, write the ratios for that specific triangle by the problem. Okay, those are the ones I was asking you to write down. Did you get them? Yeah? Okay. Now we're doing this one together, so just kind of watch me, okay? Everybody agree that is a 45 degree angle right there? This one is not labeled, but you guys understand that one is also 45? If you draw a line to the side opposite, that's a B. Opposite the other 45 is 2 square root of 2. Opposite the 90 degree angle is A. Set that up for me real quick like that. All right. Now here's why you're going to do this, okay? You're not going to have to write the 45, 45, 90, okay? You see these two go together and that says B is equal to S. Do you notice that doesn't solve anything though? It still gives me a letter equal to another letter. All right, we'll try this one. S is equal to 2 square root of 2. Does that have two variables in it? No. Do you see then B is equal to 2 square root of 2? And that's one answer. S is equal to 2 square root of 2. We already have that side, don't we? 2 square root of 2. The only side that's missing is A, right? A is equal to S square root of 2. You realize that one has two variables in it? It has the letter A and the letter S in it? But you already know what S is.
The answer is square root of 2 square root of 2.
So you're going to plug that number right there, and it's going to be 2 square root of 2 times square root of 2. Square root of 2 times square root of 2 is 2 square root of 2 times square root of 2?
2.82.
Yeah. Square root of 2 times square root of 2. It's square root of 4 inside because the 2's multiply together. 2 times 2 is 2. Notice the square root symbol is not gone away though, right? What's the square root of 4? 2. And what's 2 times 2? 4. So A is equal to 2 square root of 2 times 2. Now, some of you guys might have been getting answers off. Here's why you think you got this off. When you typed in 2 square root of 2, if you hit times right there, do you guys see that you're inside the radical still? Right there, that's wrong. Is that what some of you guys were typing in? Because if you did, that number is what you were getting. Okay? This is how it should have been typed. 2, radical 2, and then you got to realize you got to push the right to get out of that radical button, and then you can hit times. You see the difference? Now it could have gone wrong a couple other ways too. But I want you to get in the habit of trying to use your answers in simple radical formula. Okay? Do me a favor, see if you can set up the ratios, just the ratios for number 2. You don't have to solve it, just see if you can set up the ratios correctly, yeah? Don't have to solve it. All right, don't worry if you're not sure what to do. I just want to see, can you just set up the ratios at least? Yeah? All right, so where you're at, go ahead and pause for a second. Everybody agree this is a 45, 45, 90-degree triangle? You don't have to keep writing that part down. But it's just to remind you, it's s to s square root of 2, right? Here's a 45-degree angle, right? Which side and what letter is labeled with that angle? So we can put an X there. The other side should be what letter? 4 or Y?
4.
No? Y. Do you see that 4 is opposite the 90-degree angle? 4 should be right there. Okay, go ahead and put your pencils down. All right, this is really important that you learn how to set this up carefully. These two still give you a letter is equal to a letter, yeah? S is equal to Y also gives you a letter equal to a letter. You haven't solved anything. Do you see the only one that helps you is that one? And here's what you got to do. 4 is equal to s square root of 2. To get s by itself, you have to divide by square root of 2. And here is one thing, so everybody put your pencils down. You can't leave the answer like that. You can't do 4 divided by 2 either, because the 2 is inside of the radical symbol. You can type it onto the calculator. Go ahead and type it into the calculator. 4 divided by radical 2. Are you guys getting the same decimal I'm getting? Yep. All right, so watch this. Here's the rule. I need you guys to learn this and do this every time. Whatever radical is on the bottom, pay close attention, guys, because this is super critical. How's it here? Whatever that radical is, I want you to multiply the top and the bottom of the fraction by that radical. Okay? Now it looks a little weird because the 4 is on the right side of the radical, but that's not going to be square root of 8. You guys understand why it's not square root of 8 on the top? Tops multiply together, that gives you 4 square root of 2. On the bottom, you get square root of 2 times square root of 2. That's square root of 4. Now you can't stop there. Your mathematics should be strong enough to realize that, hey, square root of 4 is a perfect square, isn't it? What's the square root of 4? It's 2. So this simplifies to be 4 square root of 2 over 2. And right there should tell you, hey, 4 and 2 are not inside of a radical. Because 4 and 2 are not inside of a radical, you can do 4 over 2 and reduce it. 4 divided by 2 is 2. 2 radical 2 is as far as you can go. So that's S. S is equal to 2 radical 2. Type in 2 times radical 2 on the calculator.
3.8.
Identical decimals, aren't they? Okay. But the rule that I need you to remember is you cannot leave a denominator with a radical in it. So always multiply by that radical to the top and the bottom, and then keep trying to simplify. Okay? All right, let's see if you guys can set up number 3. You guys try to set up number 3. Does anybody need the word for number 1 or number 2 still? No? Remember, it's on the video, so, okay? All right, I'm gonna erase the work for 1 and 2. I wanna see if you guys can set up number 3. Give you 1 minute only, okay? Okay, where we were at, hopefully the first thing you did was s square root of 2. And then underneath them, you should have placed 3 square root of 2 over 2, y, and x in that order. If your letters are incorrect, here's what's happening. You're not paying attention to the opposite side of the 45-degree angle. Okay?
So then would it matter if the y would be different?
Yeah, you could have put y here, but you had to have put 3 square root of 2.
As long as it matches up still.
Remember, these two are the same, aren't they? So it didn't matter which one you plugged it into. But you guys got to get in the habit of, look at the angle, literally draw a line to the side opposite. That represents that side, okay? So, you see the first one is the one I'm going to use, because that one only has one variable in the problem. So, s is equal to 3 square root of 2 over 2. Do you realize that y is equal to s? And s is equal to 3 square root of 2 over 2. So do you guys agree that y is equal to 3 square root of 2 over 2? Those two sides should be the same, shouldn't they? Now here's the tricky part. You got to solve for x, okay? But this says x is equal to s times the square root of 2. Do I know what s represents yet? You do. I just solved it. S is equal to this number. Plug that right there. And multiply that. So write it out first. Don't start jumping to the calculators. Write it out. I finished writing it out. Take a look at what you wrote. Compare it to what I wrote. Guys got any questions right there before you simplify it?
You don't have to put over 1.
You don't have to put it over 1. I like to put it over 1 so everybody always remembers. Whenever you're multiplying, tops multiply together and bottoms multiply together. Just try to make sure nobody multiplies the square root of 2 over here with that 2 over here on the bottom. Some people like to cross multiply stuff. Only do that when there's an equal sign in between the fractions, okay? And we're not adding here, we're subtracting, so we're not trying to get a common denominator, okay? What does the top multiply to give you? Now you should be able to give me one of those values in radical form without the calculator. 4. Not 3 times 4. 3 times square root of 4. Yeah? How about the bottom? 2. All right, now before you do anything, look at what I just wrote down. Because you guys got to be able to just write that out and then use the calculator afterwards, okay? Because you guys are going to be able to, well, you're going to be expected to be able to simplify a radical. Yeah? Not give me the decimal value. But don't jump to the calculator so quickly, okay? Do you notice anything that we can still simplify? Three times radical 4. The radical 4 becomes what? 3 times 2. 3 times 2 is 6. 6 over 2. 6 over 2 though reduces to be 3 over 1, or you could just say 3. X is equal to 3. All right, you guys try to do number 4 on your own. I'm only going to give you a minute, give you a minute and a half so you can finish copying down anything you need, okay? So the one that we just did, number 4, the ratios that were, the ones that helped us first were S equal to 3 square root of 2. Since Y is equal to S, then Y was equal to 3 square root of 2. And since X was equal to S square root of 2, we plugged in 3 square root of 2 for S. 3 square root of 2 times square root of 2 gave us 3 square root of 4. Square root of 4 is 2. 3 times 2 is 6, therefore 6 equals X. So right now you guys are trying to do number 5 on your own. All right, so I'll give you a few more seconds. And again, if you rewrote it as Y to X to 6, that's fine. And that's because the sides are, remember, 2 are the same, okay? I'm going to erase my red proportions. And does everybody realize that X is equal to S? So once I find out what S is equal to, I'll know what X is. And when I found out what S is equal to, Y will be the same thing. So do you realize the only thing that's going to help me is to write S square root of 2 is equal to 6. Now to solve that, what should be the first step? How are you going to solve it? Perfect. Now, what do you think you can do right there? You're going to multiply the top and the bottom by what? Square root of 2. Remember, don't leave the bottom on a fraction with a radical, okay? What should the top give you when you multiply that? Not as a decimal. How do you write that multiplication? Just how you see it. 6 radical 2. All right, how about the bottom? Radical 4. Now you can't leave that there. Your instinct should say radical 4. You can reduce it, can't you? So that would be then S is equal to 6 radical 2 over what? Don't need a calculator to simplify that. 2 is on the bottom. Now, can I do anything further than that? There's 2 numbers, guys, that are not inside of radicals. The 6 and the 2 are outside of a radical. That means those 2 can be simplified. They give you what? 3 over 1. Or you could just say 3 square root of 2. So now that you solved for S, do you realize that X and both Y equal that number? Because X was equal to S and Y was equal to S? Yeah. Okay, we're going to have to cut it there because I'm running into the 3 o'clock hour now. Okay. Now, do you guys see how you're going to set up your ratios with the 30, 60, 90 the same way? Just different proportions. Okay.
Then you just use those to
Use
solve
the
it.
same pattern that you're trying to figure out for the variable. Okay. All right. Any questions? Getting the hang of that? Now you guys are going to have to practice and finish the rest of the code. We're officially done with you for them. So on Tuesday next week, when you come to class, all that should be done. I'm gonna give you the review sheet and you're gonna start working on it and finish it before class leaves so we can see what questions you guys may have. And that way you can practice between Tuesday and Thursday. On Thursday next week, you'll take the Unit 4 test, okay? But you'll be able to get individual help from me on Tuesday when you're working on it if you get stuck on anything, okay? 1/3 of the test involves this, the 45, 45, 90, and the 30, 60, 90 triangle. Another part of the test involves sine, cosine, and tangent. The other third of the test involves, can you tell me if the triangles are similar by side, side, side? By side, angle, side? By angle, angle? Okay, remember that? That's the whole test. Okay? The hardest parts were knowing how to use sine, cosine, and tangent, and now being able to identify if it's a special right triangle. Yeah? All right. Okay, pack up, and let's go ahead and put the